Hello everyone and welcome to today's Streamline session. Today's Streamline will be looking at the NCC 2019 Section J case study series, and this one in particular will be looking at the economy cycle and the outside air control. Before we get started today, if you have any questions, please type them into the Q&A function that's located just at the bottom of your screen, and we'll allow for some time at the end of the full presentation to go through any questions you may have. So now I'd like to introduce to you our presenter for today, Ken Thompson, who will be taking us through today's session. So Ken, I'll pass things over to you.
Welcome to the AIRAH webinar on economy cycle and outside air management. So the clauses within the code that we're going to investigate today are Part J 5.2 and J 5.3. These are the relevant clauses that cover economy cycle and the outside air management. There are other requirements in the code that address the remaining aspects of the HVAC airside systems. So you do need to be familiar with those as well. The quality of the available outside air may have an impact on the application of these clauses. So in situations where clean outside air is not readily available, then using economy cycle may not actually be a good idea, as you may need excessive filtration or other measures to improve the quality of the outside air that's being brought into the building. So it is important to not just apply the requirements of this code and these clauses without thinking about where and how they're being applied. Nearly half of the global energy used in buildings, nearly half of global energy is used in buildings, and half of the heating and cooling cost is caused by ventilation when done using the open window method, which is used around the globe a lot. So there is scope, particularly with J 5.3, around energy recovery to actually restrict the free movement of outside air and use mechanical ventilation and heat recovery to actually improve the energy performance of the whole building. So that's also something to consider as well in how you apply these clauses. Application of the clauses. So now I'll just go through the basic clauses that we are looking at. Okay, the code has two main clauses. 5.2a addresses the economy cycle, and 5.3a addresses the demand control or outside air control ventilation. Table 5.2 is based on the supply air quantity of the system, and single system we're talking about here. It's not applied across multiple systems and then added up unless they're all central systems, and you're therefore able to use a centralised economy cycle across multiple systems. So it's recognised in the code that doing economy cycle does require additional ductwork, increase in sizes in ductwork in systems, additional dampers, controls, motors, etc. So there is a cost implication involved with it, and you do need to be aware of that and make sure that you are applying the clause correctly and taking into account the use of economy cycle from a cost benefit perspective as well. J 5.3, mechanical ventilation in regards to the outside air control. So there are two methods. You can use a heat exchange or preconditioner. So you use an energy reclaim system. So that can be a preconditioner on the outside air, or it can be a energy recovery ventilator. So you can use those types of systems, and and also apply CO2 control on your outside air demand. You do have to still comply with 1668 and Part F4, and also the maximum outdoor air rate under a demand control is still 20% as per the code, 20% above the 1668 minimum. With economy cycle, outdoor air economy cycles are mode of operation of air conditioning systems where the thermodynamic properties of the outdoor air are favourable and allow you to control the internal conditions so that you maintain temperature and humidity in the space. So it's important with economy cycle that you are considering both temperature and humidity. Demand control ventilation is a way of making the system control to the occupancy levels. So the occupants in the building will release CO2, and this will then be a measure of how many people are in the building and how much outside air you need in the building. Leaky buildings will, of course, have higher outdoor air rates in them anyway and may have a CO2 demand control system in place that never actually operates because of the amount of outdoor air leakage that occurs into the building anyway. So it's more important and these systems operate better in tightly sealed buildings. Energy reclaim. So one of the methods is an energy recovery ventilator. So on the air side, air-to-air heat exchange on the air side of the system. So we're treating the outdoor air coming into the building with the exhaust air that's being released from the building and gaining some energy improvement. There are exemptions in regards to this. So what you can do is, well, you do not need to use these systems in cases where so a outdoor air economy cycle, if you've got an outdoor air economy cycle, there is an exemption around heat recovery. If you have a system where the exhaust is being used for other purposes, such as healthcare or laboratory buildings, and additional outside air is brought into the building to balance out the exhaust rates, then again, heat recovery is not going to be particularly beneficial. So there are situations, and you need to read the clauses and be aware of the exemptions when applying these systems. Okay, the system basics for economy cycle. You know, we're looking at the loads in the space and the outside air conditions. We're considering the economy cycle costs, so the cost of the system. And then we're looking at the control of the economy cycle. So there are, on the cycle chart, there is a position where economy cycle works very well, and then there's a position within the cycle chart where the economy cycle can work in a mixed sort of mode with a minimal level of assistance from the HVAC system, and then you can have then, of course, there is the section of the cycle chart where you have to use the HVAC system and controlled cooling or heating. So the choice of the control strategy and the programming that goes into the control strategy on the economy cycle is quite important to ensure that it operates in an energy efficient manner. The outdoor air sizing. So outdoor air requirements are part of the section F in the code. You need to meet the performance requirements of FP 4.3. So outdoor air is provided to a space to maintain the air quality within the space. So if you're providing outdoor air into a space that is of low quality, you're not meeting the performance requirements of FP 4.3, and that's why I mentioned earlier in regards to making sure if you're going to apply economy cycle, you have a reasonable quality outdoor air to bring in. Again, the costing and setup of the energy recovery ventilator or the demand control system needs to be taken into consideration. The code has a minimum air quality value for carbon dioxide averaged over an 8-hour period. So that's the control limits that you can use to set in your BMS. If you've got an averaging 850 parts per million over an 8-hour period, obviously your set point within your BMS will be below that because it will peak above that, and then the system will respond and then bring it back down to that level. So you need to consider what that averaging works out at and what set point you use for your CO2. So that's the system basics of the two approaches. So let's have a look at a case study. This case study is based on a office building and centralised plant. Obviously, a different arrangement will require you to consider different application of the clauses in the code. So we have a 10-storey office building. We have 4 perimeter zones and 1 central zone. Served off the 1 AHU. There are sensors in each floor level. We have 5 AHUs within the central plant room, and we have the ability to bring the outside air via a single system to direct to each of those 5 AHUs, or we can duct to the 5 AHUs separately. So this determines how we would then design the economy cycle and the or the demand control ventilation requirements. So there's a basic layout of the floor plate. We have the perimeter zones, north, east, west and south, and the centre zone around the whole building. It's a 1,000 square metre floor plate with a central core, so it's split up. So the NLA of the building is 9,000 square metres, and then we run that through Camel to determine what the supply air rates and the outside air rates are in accordance with 1668. So central plant means all the outdoor air enters at the same point in the building. So the Camel there, you can see we've got the outdoor air rates. Got the outdoor air rates in the Camel there, and we've got the supply air rates. So we'll have a look at those in the next couple of slides under the compliance requirements. So for the Camel loads, for determining the economy cycle, I ran the Camel loads for 2 locations, Melbourne and Brisbane. And so you get different supply air rates and requirements based on the climate zone, and the outdoor air rates remain the same because it's based on occupancy levels. So as you can see in the code, from table J 5.2, economy cycles required for 2,000 litres a second supply air or above. And for the Melbourne application, every single zone has more than 2,000 litres of supply air. Therefore, all systems or all air handling units in the office building in Melbourne would require economy cycle. However, when compared to Brisbane, the supply air rates are lower than the table requirements for economy cycle. We only require economy cycle if the units are above 9,000 litres. What you can see there in the table is that only the centre zone has more than 9,000 litres. The west zone is very, very close. It's only 100 litres off meeting the requirement. So potentially, as this is a central system for this building, potentially you could apply economy cycle across all zones because it's probably going to work out fairly similar from a cost perspective to applying it to just 2 zones. So it does depend on the building. It may be best practice in this case to still apply economy cycle for the Brisbane climate zone for this particular building. From a code perspective, though, only the centre zone will require the economy cycle. For the outside air management, so either CO2 or heat recovery ventilation for Brisbane, you do not need any outside air management control on the climate zone 2. However, for Melbourne, if the systems have more than 500 litres of outside air per system, then the outdoor air is required to be managed. So for the Melbourne, you would either use heat recovery or CO2 control on that outdoor air. So let's have a look at the design elements in applying economy cycle. A typical air handling unit that has economy mode will require it to be able to do close to 100% or 100% of the supply air rate through the outside air damper. You may, depending on your design, have slightly less than 100%. It will depend on your enthalpy calculations and your system sizing and your application. So you'll need to size the air handler and the outside air dampers and everything to achieve the outdoor air and relief air paths required, and then set up the controls and everything to achieve that as well. So for the economy cycle, it's important that there's a call for cooling. The outside air has the enthalpy that allows the system to work correctly, and that the outdoor and internal air temperatures and relative humidities are both within the operating limits. So you achieve that by ensuring that the set points for the operation of the economy cycle within the BMS or control system are set correctly to achieve those outcomes. For the outside air control with demand control, so CO2, you'll have a CO2 sensor in the return air path or within the spaces at each floor to check the CO2 levels, and then that will determine the control of the outside air damper. The outside air damper will open and close in response to those CO2 levels, as opposed to a system without outside air control. You can see in the graph there, it would just be open. The outside air rate will be open and operating based on just the on-off requirements of the system, and then switch off at a certain time. the outside air economy cycle, the CO2 control system will respond to the CO2 levels within the space. A heat recovery ventilator, so an air-to-air heat recovery ventilator. You can also use a water-to-air heat recovery system, but an air-to-air heat recovery ventilator is added to your air handling unit, typically on the outside air and the relief or exhaust air path, and this then treats that outside air as it comes into the system. And so you have improved conditions, temperature and humidity conditions on your outside air. You can either use sensible or sensible and latent heat recovery ventilators, and you have to achieve a certain level of effectiveness of those ventilators to then attach to the economy, to the air handling unit. A air to water heat recovery, or a runaround coil as it's sometimes referred to, can also pre-cool or precondition the warm and humid outside air, and so that type of system can also be used to pre-treat the outside air coming into a system. So it just depends on your application as to what's most suitable and will provide the greatest level of energy efficiency for your design and your system. Ductwork and dampers, in a economy cycle, you're going to require additional motorised outside air dampers, return air dampers, relief air or exhaust air dampers that are all have integrated controls and motorised. You'll have larger, typically larger return air duct or relief air duct in the system for when it goes into economy mode and is supplying 100% outside air, so that you're allowing the system to pressure balance in the space. For the outside air management and the so the CO2 control and the heat exchanger, you'll have a motorised outside air damper control via a CO2 sensor, and that's fairly simple and easy to add to a system. Or you'll have a heat recovery ventilator with its own controls on dampers, etc., where it operates within certain set point limits. So you have both of those. You can those are the controls and requirements for both of those systems. You'll have the additional ductwork, etc., for the energy recovery ventilator. So you also have to consider the sensors and controls of these systems. For economy cycle, you've got a minimum required information around the return air temperature and enthalpy, the temperature and enthalpy out of the outside air. You have lockout conditions in your control strategy where if the outside air temperature and humidity are not suitable, then it locks out the economy cycle. You have conditions for activation and then an enabling time. So you don't want the economy cycle jumping in quickly and then the outside conditions change and then it jumps back out again. You don't want a fast response time there. So you put an enabling time in for the control of the economy cycle. So you need field sensors, DDC controllers, software, dampers, outside air dampers, relief air dampers, etc., all motorised, and size to accommodate typically up to 100%. So for the outside air management systems, for CO2 control, we typically will have CO2 sensors either in the space or in the return air duct, and a motorised damper on the outside air, and that will allow you to control based on the signal coming back from that CO2 sensor. So now what I'm going to broach is the requirements within the code around effectiveness. So the code actually states in the clause, an energy reclaim system that preconditions the outdoor air have a minimal sensible heat transfer effectiveness of 60%. So the term is effectiveness. Effectiveness is related to the volume of the fluid flow and the rate of heat exchange between the fluids. Efficiency of a heat exchanger. So I'll just show you a couple of the equations that are used to calculate effectiveness of heat exchangers. So a air to water heat exchanger effectiveness has the following equation. I'm not going to go into details of the equation. You can find these equations on the web, and they determine the actual effectiveness of the heat exchanger. And be careful, typically product suppliers will quote a heat exchanger efficiency as opposed to a heat exchanger effectiveness. So we'll go into that in a little bit of detail as well. So that air-to-air heat exchanger effectiveness based on the heat transfer and the actual volume and transfer between the particles of the supply or the outside air and the exhaust air across that medium, that heat exchange medium in the air-to-air heat exchanger determines the effectiveness. For efficiency, the air-to-air heat exchanger efficiency is a relatively new concept, and it's just the ratio of the actual heat transfer in the heat exchanger to the optimum rate of heat transfer. So it's just a calculation that's based on the temperature differences between the incoming air on one side of the heat exchanger and the outgoing air on the other side of the heat exchanger on both pathways. And it's a determination of the heat exchange that occurs based on those temperature differences. That works perfectly if you have equal volumes of airflow through each path of the heat exchanger, and then the efficiency and the effectiveness are basically the same. But if you have differing volumes of airflow through each path on the heat exchanger, you will not be able to equate efficiency to effectiveness. So just be careful of that. In the code, it does ask you to provide equipment that has a effectiveness of a minimum of 60% for sensible heat transfer. So in conclusion, and then we'll go to questions. So the two things we've just had a look at in the code are economy cycle and your outside air management. J5.2 and J5.3 are the clauses. They are climate zone specific, so they do not apply across all climate zones. You need to consider ductwork controls, air handler configurations, total system design, etc., sensors, BMS requirements. Consider the overall building as well as the air conditioning system. It might be better practice in certain instances to include economy cycle, even when the code doesn't require it. But also remember, you must meet F4 requirements and 1668 requirements as well in determining these systems. Okay, so let's have a look at the questions that have come through. The first question was section J 5.2. List the total air of the system or the outside air. So 5.2 is the total supply air of the system. I used, so I'll just answer that live, just with the software used to model the case study. I just used Camel. It's not, it's just to determine the supply air rates and sizing of the system, so I could determine whether to apply economy cycle or not as per J 5.2. No, Camel doesn't, not that I'm aware of, have a automatic code compliance option. VAV systems, VAV systems have a required outside air requirement in regards to 1668, and then you adjust the outside air volume down to a minimum set point on your VAV system based on your control strategies and your percentage control on your VAV system, which will be based on your minimum supply air rates to a space, and then the proportion of outside air that's supplied to that space will be the proportion of outside air compared to the proportion of supply air for the space. So you then need to make sure that you still meet 1668 minimum outside air rates into the space on a per square metre rate, not an occupancy rate. So you do have a minimum VAV turn down that you can achieve. It's not uncommon for large FCUs in ceiling spaces that would require an economy cycle to be split into two smaller units that serve the same space in order to fall under economy cycle limit. No adequate spill air path can be provided and or increasing the outside air ductwork is not feasible. No, it doesn't assist in energy efficiency and reduction of energy efficiency in the space. Yes, economy cycle is strictly done based on individual system sizing. So the practice of splitting into two systems in a foyer, you do then, if you split it into two systems and you design those two systems quite well, you could actually control the two systems so that at low load only one system runs. So then you'll get the energy saving required anyway. May not quite give you as good an energy saving as being able to use economy cycle, but it'll still give you an energy saving. Up to you how you go about designing those systems. Typically, you can't use kitchen exhaust air in a heat recovery situation. In regards to economy cycle, yes, you would definitely use economy cycle for the makeup air path for a kitchen exhaust, because you're increasing your outdoor air rate to balance your kitchen exhaust requirement anyway. So in that situation, you most definitely can control your air handler unit or fan core unit and have it operate in economy mode if the outside air conditions are suitable, and you're needing to ensure that you're exhausting enough air through that kitchen exhaust system. So have a think about how you've designed your system and what's going to be most energy efficient. And yeah, I would definitely look at using economy cycle. For DVC, so demand control ventilation, yeah, you need a CO2 sensor in each room or zone or in the return air. So one sensor in the return air is sufficient, most likely, depending, like in the case study, that would be in the return air per floor. So not the return air at the plant room, that would be a return air sensor per floor, because if one of the floors switches off, which it may need to do under Section J compliance requirements, then your outside air control to that floor, you're switching that floor off, you're not, you shouldn't be then using that sensor for that floor, and your total outside air rate would then also be adjusted on the requirements. So you'd need to code that into your BMS system. So it would change your set points, etc., on your system. What do I mean by F4 requirement? You need to read the code, the NCC. Section F4 is the performance, code requirements for health and amenity. So if you're doing HVAC design, you need to know Section F4 as well. So have a read of it. Section J states that outside air is to be no more than 20% greater than the F4 requirements. It does not fit in with the Green Star requirements. That's why you then do a JV3. Good question, Karen. You need to, if you're doing a Green Star building, you are not meeting the deemed to satisfy requirements of Section J. You therefore are doing a JV3, you are having higher outdoor air rates, and you're energy modelling the whole building. What's the best control method for economy cycle, enthalpy or dry bulb temperature? The best method is enthalpy control, because you are controlling the humidity as well. If you just control economy cycle on dry bulb, you could have a 19-degree dry bulb temperature, 95% humidity because it's raining outside, and you'll end up with 24 degrees inside and 75% humidity inside, and people will feel very, very uncomfortable. So you do need to consider enthalpy, or you do need to use enthalpy control. I would not do economy cycle based on dry bulb only. Design AC supply air quantity will change based on supply air temperature for a given load, potentially changing the requirements of the economy mode. So any requirements for design supply air temp to be fixed in the BMS? No. VOV systems will vary supply air rates. If you're running a VOV system in economy mode, you'll therefore have your outside air rate adjusting in accordance with the supply air requirements for the spaces based on your VOV control. You need to make sure your BMS system has those algorithms in place and adjusts control accordingly. Is ASHRAE 90.1 a consideration to be included during economy cycle design? I'll need to take that question offline. I don't quite understand the question at the moment. So maybe, Glenn, can you send that question to Marie, maybe with a little bit more detail? No, there's no software template available for automatic code compliance. Sorry, you need to calculate it or build your own detail sheets or software. How to have economy cycle on different zones with centralised system. It's all in the BMS control, the damper positioning on each of the air handlers. The economy cycle can adjust the outside air rate through the total system, and then each air handler has dampers, etc. as well, so you can then adjust what goes up to each zone. It's just all in your control strategies. Are there instances where ambient dry bulb provides more efficient control than enthalpy? Yeah, there are. If you don't have humidity issues, you have low humidity or fairly consistent humidity levels, you'll probably find that dry bulb will probably be as effective as enthalpy control. You need to consider that based on your climate zone position. What should be the minimum economy and cycle enabling time? What might the impact be of this time? Need to determine that based on system design, building type, etc. What response times are appropriate for your building? I have done systems where we've made it about a 15-minute economy cycle enabling time. That's so that the times when you get sensors giving you information for the outside air that says, you know, it's fine for economy mode, but it only lasts for 5 minutes, and then the outside conditions change and it's not quite suitable for economy mode again. So yeah, you need to consider that in your BMS control strategies. During economy cycle mode, how can you control the supplier temperature to the space? Are the chill water valves or heating water valves still required to modulate? So that's when I said earlier you can run economy cycle either in the site chart. You've got a portion in the site chart where it's full economy cycle, so no chill water valves, heating water valves are off. Then you've got a period where you can modulate chill water valves and heating water valves and still run mostly economy mode, where you'll just do a minimal amount of cooling or heating. And so that's quite effective from an energy perspective. And then, of course, you jump up the site chart to the point where you've got full control via the chill water system or the heating water system. Same with the DX system, if you've got that capability in your DX plant. The 1668 requirements on outside air have a minimum outside air rate on a square metre base for spaces. So yes, your VAV turn down is based on that. So if an unoccupied space, you're still providing a certain amount of outside air. So your CO2 control goes down to that minimum point. Andrew Prentice, yes. I'll need to take that question offline. Marie, if you can take that question, I'll need to do a little bit more work on that one. Some climates, energy recovery are often determined to use more energy annually due to the pressure drops. The determination of the heat exchanger or sizing based on the outdoor air rates is based on making sure that it is energy efficient and therefore provides an energy saving annually. And it does take into account pressure drop, supply and exhaust fan, energy consumption, etc. So if you have a situation where you have calculated that it's not more energy efficient to provide the heat exchanger, and you've got all your calculations and you can determine that it's not more energy efficient, then that would be your performance-based solution for excluding the heat exchange and not meeting that code compliance requirement. And that would be it. So you would therefore just have some calculations that demonstrate that your performance-based solution says I don't need a heat exchanger because it's less energy efficient. If that makes sense. If you don't have exhaust from the space, then you don't have an energy recovery ventilator because you don't have the exhaust air to use to energy recover from. So no, you then do not need to comply with that clause. Interesting statement, Greg. Thanks for that. Yes, it would. You do need to commission and locate your CO2 sensors appropriately to ensure that they do operate correctly. So part of your commissioning process and your location, your CO2 sensors, is in ensuring that they do operate and read correctly, and there is calibration required. So yes, sizing dampers and ductwork appropriately to achieve the airflow velocities that allow the sensors to operate correctly is also something you should take into consideration. Thoughts on PMV modelling? Not really the forum for that question, so I'll just leave that one. No. Interesting question. J5.2, applicable for evaporative cooling systems. An evaporative cooling system could operate in economy mode by just turning off the water supply to the cooling system, to the evaporative cooler, and hence still run the fans. We'll have to do a little bit more digging to find out whether that's actually intended within the code. Matthew, yes, 48 kilojoules per kilogram is a value that I remember using as well. I have seen slightly different values used. It does depend on the application and the indoor air conditions as well. Obviously, if you have slightly higher internal temperatures, etc., available, then you might be able to use slightly higher enthalpy values. And then if you're controlling to lower or tighter temperatures for the internal conditions, you might need lower enthalpy values. So it does depend on what internal conditions you're trying to control to.
Thanks for that, Ken. I think that's all the questions. So good work getting through all of those. So we might wrap it up there, everyone. So thank you, everyone, for coming along to today's session. And special thanks to you, Ken, as well, for conducting today's presentation. Just to let everyone know, the webinar has been recorded and it will be made available to the public over the next couple of weeks. And I'll send out an email and let you guys know when that does become available as well. To register or view any of AIRAH's other upcoming Streamline sessions, hopefully you can see them on the screen there. We have some coming up over March, so please feel free to check them out on our website. If you have any other further questions from today, as Ken mentioned, please feel free to email me directly and I'll pass on any of your questions straight through to Ken. So thank you again, everybody, and we look forward to seeing you again soon. Thanks, everyone. Thanks, Ken.
Thank you.